Welcome, my dear students. Today, class is on the topic more file attributes. So, in this class, we will discuss on file system and inodes, hard links, umask command, and then find command. First, the file systems and inodes. So, we will discuss first the concept of file system, and inode stands for index node. That is a lookup table contained almost all the attributes of a file. Then what is a file system? As you know, everything in Unix is considered as a file, including the physical devices. So as the files grows, it is difficult to locate the files. So Unix organizes all the files in a hierarchical file system structure, much like the up-down inverted tree with root directory at the base, okay, and all other directories spreading from there. So this diagram shows the Unix file system. So root directory is identified by the forward slash, okay, and the root directory we have the subdirectories like bin, tmp, users, src, and so on. So the Unix file system is a collection of files and directories. So here, each physical drive can be divided into several partitions. That means Unix divides the hard disk into logical disk called partitions. Each partition can contain one file system. Say, for example, slash directory is one file system, slash bin is one file system, slash temp is one file system, slash users is one file system, like. And each file system has its own inode table or index node table. And each file is assigned an inode number which is unique within the file system. All attributes of a file except its name and contents are available in a table inode accessed by the inode number. So the inode number points to the inode. Okay. So information of a file can be accessed through this inode number. So what is inode? The inode contains the following attributes of a file. So the inode is a data structure containing all the attributes of a file. So which attributes of a file? File type, which may be regular, directory, device, etc. Then file permissions, number of links, the UID of the owner, user ID of the owner, the GID of the group owner, the group ID, file size in bytes, date and time of last modification, date and time of last access, and so on. Say, for example, kernel wants to access the information about the file with an inode number 15. Then what it does, the kernel scans this inode table or simply inode to find an entry with an inode number 15 in order to access the necessary information. So how do you get the inode number of a file? To know the inode number of a file, issue the ls command with -i option. Say for example, I want to know the inode number of the file myfile.txt. Just execute the ls command with -i. Of course, you can combine the option L for long listing. So this is the output of the command. If you observe the first field, okay, 9051. So is the inode number of the file myfile.txt. So each file is assigned an inode number when the file is created by the kernel. So all the information of the file is accessed using this inode number. So this inode number points to a table inode, okay, which contains all the attributes of the file. Then hard links. You already know the attributes of a file. If you observe the attributes of a file, here say for example, so I have listed the attributes of the file emp.list. Okay. So in this attribute list, the second column is really the hard link. So what this hard link corresponds to? It corresponds to number of files that references the original file. That means to say a Unix file may have multiple names. So I can give an additional file name to the original file name. Okay. So then what is hard link? A hard link is a reference to an existing file, original file, not a copy of the file. So if the original file is deleted, the information will be lost. So a hard link, in other words, is used to provide alternative means of referencing a file. That means a separate link exists for the same file contents. Then the question is, how do you see the hard link count of a file? That means whether a link exists for the original file. So you have to use the ls with -l option. So the second column really is the number of hard links. See, this is the example. So this second column is really the hard link. So as I said, this count is normally 1 when the file is created. A file with a link count of 1 has no hard links. So right now, this file does not have any hard link. Okay. Then the question is, how to create a hard link? So the answer is ln command. So ln command is used to create an hard link. So a file is linked with the ln command, which takes two file names as arguments. So syntax of using this ln command, ln options, then the next argument, existing file name or original file name, then The third argument is new file name. So an example here. So I want to link emp.list with other name, that is the employee. So then just go to the prompt, just type ln followed by the existing file name, then the new file name. Existing file name is emp.list, then the new file name is employee. So when you execute this command, you can refer to the file either by using the emp.list or the employee. Then when you create an hard link, both the files have the same inode number, meaning that they are actually one and the same file. Okay. So how do you know the inode number of both these files? In the example, just use -i option with ls command. Okay. So here is the example. So go to the prompt, just type ls followed by -li, then the file name emp.list and employee. Specify both the file names to know the inode number of these files. Okay. See here, observe the output here. So this is the attribute of the file emp.list, and the second row is the attribute of the file employee. So see the first field, the inode number. So inode number of both the files are same. So the link count, which is normally 1 for unlinked files, is shown to be 2. You observe the file output here. Now the link count is increased to 2. So a file with link more than 1 has other names. Then the next topic, umask. What is the significance of knowing the umask command? Okay. So as you know that every file and a directory is assigned the access rights for the owner, group, and other users. Okay. So the default permission set for the file and directory upon their creation is this: read, write, no execute for owner; read, write, no execute for group; read, write, no execute for others. So this is relative permission, and in absolute permission it is the octal value 666 for regular files. And for directory, what is the default permission set? Read, write, execute for owner; read, write, execute for group; read, write, execute for other. And in absolute permission it is 777, the octal value. This is for directories. Actually, this is not the actual default permission. So the default value is transformed by subtracting umask value from it to remove one or more permission. So this default value is transformed by subtracting umask value from it to remove one or more permission. So then what is umask value? Umask value is used to set the default permission of a file and directory while creating. Okay, so this is used to change the default permission of a file and a directory. And how do you see the default um, mask for the file or directory? So answer is use the umask command. So umask command is used to see the default mask for the file or directory. So here is the point. Okay, to display the current umask value, use the umask command. So I will go to the prompt and just type umask. Okay, so see, observe the output. So the umask values 0 to 2. Okay. So what is the actual default permission set for file and directory? So here how the computation will be done. The computation that takes place during their permission assignment is shown below. So this is for file. So it will subtract the umask value 0 to 2 from 666. Okay. So then what is the result? 644. Okay, so which is read write. So read is 4, write is 2. It is 4 plus 2 6. No execute. Read, no write, no execute. So read is 4. Okay, this for others. Sorry, for groups, and for others read. So that is 4. No write, no execute. So then it is 644 for files. And similarly for directory, the umask value is subtracted from 777. Okay, and the result of subtraction is 755. Okay, so which is actually read, write, execute. That is 7 for owner. Read, no write, execute for group. That is 5. Read, no write, execute for others. That is 5. So this is for directories. So this is the actual permission that is set when the file or directory is created, and not this. Then the next topic, find command. Find command is used to locate files. Okay. So find command recursively examines a directory tree to look for files matching some criteria, and then take some action on the selected files. What do you mean by recursively? So this find command begin looking in the directory you specify and proceed to search through all accessible subdirectories to look for files matching some criteria, and then takes some action on the selected files. Simply, the find command is used to locate files in the Unix system, okay, based on some matching criteria, and it will take some necessary action on the selected files. So the syntax of using the find command, the command name is find, then it takes 3 arguments. First one is path underscore list, path list. Second one is selection criteria, and the third one is action. So what is path list specifies the directories to start the search. That means where to look up for the files. Then the selection criteria. So criteria for the actual search, and then the action that you will take on the files that you found. So how this find command works? Working of the find command, it recursively examines all files specified in path list, this path list. It then matches each file for one or more selection criteria. Finally, it takes some action on those selected files. Then there are various options for matching the criteria, this selection criteria. So what are those options? -num n. So searches for files having inode number of n. So second option for matching criteria, -name followed by the file name. So it searches for certain files with file name, file name. -type x. So searches for files of type x, where x can be type of file, f for ordinary file, d for directory file, s for symbolic file, and so on. Then the next option, -permission followed by p. So searches for files with permission p. P is an integer value. Then the other options for selection criteria, -size n, searches for files with size n bytes. Suppose +n, if the size is +n bytes, so it will match files larger than n bytes. Suppose it is -n bytes, sorry, -n bytes, match files smaller than n bytes. Then the next option, -user followed by the username. So it will searches for the files owned by the user. Then there are some options for action component. -print prints selected file on the standard output. -exec command execute command cmd on the selected file. -ls execute ls command on selected files. -mtime x searches for files based on the modification time. If x is the number of specify the days, if it is +x, it will search for files modified more than x days ago. For -x, it will search for files modified less than x days ago. So examples of using the find command. So say for example, we want to search for files in the whole system, that is from the root directory, for the file named a.out. So search for files in the whole system with a.out. Then, so what is the find command? Find the path list. So you have to start search looking in the whole system, that is from the root directory. Okay, from the root directory and the subdirectories. And then what is the selection criteria? So we want to find files with name a.out. Then the option I have to choose is -name followed by the file name. File name is a.out, and the action argument. So you choose the print, -print. So that will print the selected file on the standard output, that is on the screen. See, this is the output. Okay. So this command will search in the root directory for the file named a.out. Okay, and the -print option will print the path of any file path of any file that is found with that name. So there are 3 a.out files in this path. So second example, find and report all files with extension .c in the current working directory. So the path list argument value is dot, that is current directory. Go to search starting from the current directory, and selection criteria is you have to find files with extension .c, that is hyphen name followed by the file name is star.c, and then you have to report it. So the action argument is hyphen print. So then it will display all the files with extension .c in the current working directory. So these are some of the exercises that I can take it as homework. So let me demonstrate. So whatever I have taught so far. Let me go to the online Linux terminal. So first demonstration, how do you know the inode number of a file? First, let me create a file. Say file name is myfile.txt. So to know the inode number of a file, issue ls command with -i option. Of course, combine with L option for long listing. See here, 385 is the inode number of the file. myfile.txt. Then how do you create an hard link for a file? Let me create an hard link for the file myfile.txt. So right now, what is the link count of this myfile.txt? It is 1. So it is not referenced by any other name. Okay, no other links right now. So let me create a link for this file. So how do you create a link? Using the ln command, ln myfile. So this is the existing file. You give the new file, say emp.lst. Now, after executing this command, you can refer to the file either by myfile.txt or emp.list. So let me display the contents of the file emp.list. See, and now check the inode number of both the files, myfile.txt and emp.txt. So use the ls command with -i option to know the inode number of both the files. See here. So the same file is emp.list and the inode number is 385. So myfile.txt inode number is 385. Because both they are the one and the same file. Inode number are same. Then how do you know the umask value? Just type the umask command. See, 022. So umask command is used to know the user mask value for a file or a directory. See the default permission set for the file. myfile.txt. Sorry, typing mistake. See here. Now it is 644. Okay. This is done by subtracting the umask value from this previous default permission. There is 666. 666 minus 022 is 644. So this is for ordinary file. So similarly for a directory also. You can create one directory using mkdir. Say d1. Check the attributes of this directory. d1. See here the permission for this directory. 7. This is 7 for owner, 5 for others, 5 for groups. Read is 4, write is 2, execute is 1. 4 plus 2 plus 1, 7. So read 4, execute 1. 4 plus 1 is 5. This is for others. Similarly, read is 4 and execute is 1. 4 plus 1, 5 for others. Sorry, this is for groups, this is for others. Let me see the hard link count of the file myfile.txt and um, emp.list. See, now the hard link count is increased to 2. Then our demonstration of for the find command. So we'll take the example 2. Let us find and report all files with extension .c in the current working directory. So let me create some files with .c extension. Now I want to find and report all files with extension .c in the current working directory. So just execute the find command in the current working directory. So dot refers to the current working directory. That is the path list. Then the selection criteria. I want to find the files with extension .c. So the option is -name followed by the file name star.c, and I want to report. So what is the action? -print. So see the output. See here. So enclose the star.c and with the double quotes. Okay. See here. That indicates the current working directory. So it has located files with .c extension and reported. So this is the observed path name of both the files. That's it for the today's class. Hope all of you have understood this.